Hello, this is Prof. Aram, and in this video we are going to look at a special kind of cash flow, and that's called an annuity. These are even cash flows, equal cash flows that happen at equal intervals of time, and they are finite. So let's get to this. As you can see, here's the definition for the annuity, which is pretty straightforward. An annuity is a series of constant or level or equal cash flows that occur at the end of each period, and it's finite. There is another type of annuity which the cash flows happen at the beginning of the period. That's called annuity due, which I'm going to cover in the next video. But this one, we call this an ordinary annuity, in which the cash flows happen at the end of the period. You can see that you're receiving $100 at the end of each period. They are equal amounts and they are finite. So there is an end to this series of cash flows. In fact, it is very common for financial instruments to have multiple cash flows that are the same amount, such as, for example, car loans, home mortgages, your insurance premiums, and so on and so forth. So this is very common in finance, and we're going to learn how to find the present value of an annuity, future value, the payment, the rate, and the number of periods. So let's see how we can calculate those. In the financial calculator, remember, we have never used this before, the payment. We just skipped it all the time in the previous lectures. But here, we're going to start using the payment function. The payment function assumes that every cash flow happens at the end of each period. And these cash flows that you enter in the payment are equal cash flows. And there is a end, or there is a finite duration for this series of cash flows. And to find the present value of the annuity, you multiply the equal cash flows or payments by the annuity factor, which is this one. And then for future value, you multiply the payment by the future annuity factor, which is this one. So let's look at an example. After carefully reviewing your budget, you have determined you can afford to pay $632 monthly toward your new car. And you call your bank and find that the going rate is 1% per month for 48 months. Remember, so far we had annual compounding, so we used the annual rate. But here, since we are having monthly payments, we need to have the monthly rate. So the number of periods should always match the periodic. So what do I mean by that? It means that if the number of periods that you have are in months, then you need to have monthly, which is your annual percentage rate over 12, right? I'll discuss this in more detail, but just so you know, when we define the future value in the first time value of money lecture, this was annual and T was in number of years. But remember, T is the number of periods, not the number of years. And R is the rate of return for each period. So it can be months, days, quarters, or 6-month periods, semi-annual periods. So that being said, your payments are going to be $632 per month. Your IY is 1% per month, and then the number of periods that you have is 48 months. To determine how much you can borrow, you need to calculate the present value of these series of equal payments, or the present value of this annuity, to see how much you can borrow. So to borrow money today, you need the present value. So in this case, your N would be 48. Your IY would be 1. Your payment is 632. And you need to calculate present value. Right, so let's do this. So first of all, before doing anything else, I'm just going to clear the time value of money function. So the payments that we have to pay is $332. So since we are paying them, I'm going to put a negative sign here. The rate is 1% per month, and we have 48 months. We can calculate the present value, $23,999. In Excel, you have the monthly rate, you have the number of periods, and then you have the payment. You can calculate the present value like what we used to do for other situations. So we have the rate, which is 1%. Number of periods is 48. Now we have payment. So we can't skip this. Of course, we don't have any future value or type here, so I'm just going to close this and have the present value of $23,999. Let's look at another example. Suppose you win the Publishers Clearinghouse $10 million sweepstakes. The money is paid in equal annual end of year installments of $333,333. And if the appropriate discount rate is 5%, how much is it actually worth? How much is the present value of this annuity today? I'm going to do it first in the in the BA2 Plus. We have 333,000.33 cents for the payment. You receive it in 30 years, and our annual rate is also 5, so we can calculate the present value. So in fact, given this 5% discount rate, this $10 million that is paid over 30 years, the present value is just $5,124,150. Okay, we can do the same thing in Excel. So present value would be the rate for 30 years and the payment exactly the same number. Let's say you want to find the payment. You know that you want to buy this $20,000 car, and you know that you can borrow 8% per year compounded monthly. You're going to pay monthly payments. You want to know how much do you have to pay each month. So in the timeline, you know your loan amount today, the present value. You know how many months you're going to make payments, and you know your IY, or the rate, is this. How much are you paying each month? So we are solving for payment in this case. Let's do this. Clear. Time value of money function, and then we start with the present value. You're borrowing $20,000 today. 8 divided by 12 will give you your monthly rate. 4 years times 12 will give you the number of months, and then you will calculate the payment. So if you borrow this money, the $20,000, and make monthly payments with a annual rate of 8% compounded monthly, you have to pay $448.26 each month. in Excel. All you have to do is just solve for payment. Where is it? Here. Your payment would be your rate, the monthly rate. Number of periods is going to be 48. And the present value of this loan is $20,000. Payments that you have to make every month is $488. We can also look at, for example, how long does it take to pay off the loan in this case. So let's say you ran a little short on your spring break vacation and you put $1,000 on your credit card and you can afford only to pay the minimum payments of $20 per month. So if the monthly rate is 1.5%, how long does it take for you to clear this debt, to pay off your loan? So keep in mind, for this one, because you have the present value and the payment, one of them should be negative. If both of them were positive, you would get an error. So let's just calculate the number of periods. Rate is 1.5. Payment is 20. And then PV is 1,000. I mean, I'm not getting an error, but you cannot have a number of periods that is negative. So if I change this, it will take 93 months or about 7 or 8 years to pay off this loan. So if you want to do the same problem in the financial calculator, it will look like this. $1,000 is the present value. 1.5 is the rate, and you're going to make $20 payments. You want to calculate how long. So again, it doesn't make sense, so I'm going to change this to a negative number to have a positive period. And you can calculate the future value of an annuity. If you have the payment amount, the rate, and the number of periods, you can calculate the future value. Future value would be the rate, number of periods, 40, and payment, and the future value would be $454,513. Let's do the same thing in here. So 2,000 for the payment, 7.5 periodic rate, 40 periods. 40 is your N. You can compute future value, exactly the same number. I hope you find this video useful, and thanks for watching.